Hi everyone, welcome to Cloud Computing series. In the previous video, we had discussed till cloud computing model. So today we'll start with distributed system families. Yes, see, in the 1990s, scientists started connecting many computers together to create a large computing networks, and these networks were built using a peer-to-peer systems and clusters of computers. Yes, government and research institutions combined these technologies to create huge shared computing networks called computational grids or data grids. For example, a computational grid is like a network of universities sharing supercomputers to run advanced research projects, right? See, SETI at home is a real life example where people share their home computers to help search for alien life. See here, a cluster is a small group of computers working together. But when we connect a multiple clusters over a network, we create a networks of clusters that can handle a huge tasks. For example, a small restaurant kitchen is a one cluster, but a big chain of restaurants working together is called networks of clusters. Then the next point is, see, internet clouds are the result of moving a desktop computing to service-oriented computing using server clusters and huge databases at data centers. That means instead of running a programs on a personal computer, cloud computing runs them on powerful remote servers, right? These servers are organized into clusters and store massive amounts of data in a data centers. For example, instead of installing Microsoft Office on our computer, we can use a Google Docs, right? Yes, which runs on cloud servers. Then instead of storing our photos on our phone, we can store them on Google Drive or iCloud. Is the next. So, this chapter introduces the basics of various parallel and distributed families. Parallel means many computers working together on a single problem, but distributed computing means many computers working on a different tasks but share the same goal. Yes. Yes, the next point is, see, computational grids and cloud computing are different but share a common goal, that is sharing resources like a hardware, software or the data, and making computing more efficient by letting users access powerful machines remotely. Yes, for example, see, grid computing, example for grid computing is universities share supercomputers to process scientific data. And for cloud computing is companies rent servers from AWS or a Google Cloud instead of buying their own. This, this next is, see, both high performance computing and high throughput computing use multiple computers working together, and they both rely on parallelism and distributed computing. Yes, the next point is, in the future, computers must handle high throughput, that is finishing number of tasks per second, then efficiency, using energy wisely, and scalability means expanding without slowing down, then reliability, keeping systems running even when parts fail. And the next point is, see, massively distributed systems are intended to exploit a high degree of parallelism or a concurrency among many machines. Massively distributed systems means thousands or millions of computers working together at the same time. Yes, then parallelism means many computers working on the same task. Then concurrency is many computers working on different tasks at the same time. For example, Bitcoin mining uses thousands of computers to solve cryptographic puzzles, right? Then Google search uses many servers to handle millions of searches per second. Next is, see, a computational grid is a network of supercomputers connected together. Some grids can have hundreds of clusters. For example, the European grid infrastructure connects the supercomputers across Europe for scientific research. See, in a peer-to-peer network, millions of personal computers work together instead of using a central server. This makes it faster, efficient, and decentralized. For example, Skype used a peer-to-peer net technology to enable direct video calls between the users. Yes, the next point is experimental cloud computing clusters have been built with the thousands of processing nodes. That is, scientists and companies are building a test cloud systems using thousands of processing units, right? These clusters help researchers test new cloud technologies before making them available to everyone. Yes, for example, Google and Amazon test new cloud servers before launching them for a public use. Okay. Next is, see, goals requires to yield the following design objectives. First one, efficiency. Yes, means how well computers use their resources like speed, energy, or a storage, right? Next one is dependability. That is how reliable the system is, and even if something goes wrong. Yes, see, adaptation. That means how well it handles billions of requests and massive data sets. And lastly, flexibility means how well it runs both scientific and business applications.